Hey guys, we're back with paper 2H from November 2007 for chemistry, and this is part 2. Alright, so we left off with question 5A, and what it's telling you to do is draw a dot and cross diagram to show the covalent bonding in a molecule of hydrogen chloride. So the formula for hydrogen chloride is just simply HCl. And you gotta only show outer electrons, meaning no inner electrons, please. And yeah, so I'm just gonna help draw it for you. So you have, first of all, a molecule of H, and this is just H. That's the nucleus, that circle which I just drew. And you have another molecule of Cl, and that again is the nucleus. And what happens is, this is the outer electron shell of H, and this is the outer electron shell of Cl. And the intersection of the two outer electron shells show that there is covalent bonding because they're sharing. So in this case, hydrogen has one electron in its outer shell. So that means that this one electron will be shared with Cl. And Cl will share one electron as well with hydrogen. Okay, and that's the electron of Cl. That's the electron of hydrogen. Okay, and Cl also in its outer shell has 7 more electrons. So has 6 more electrons, excluding this one over here. Okay, so 6 more electrons. So 1, 2, 3, 4, 5, 6. So as you can see, both electron shells are complete, and they're both sharing 1 electron each, and so 2 electrons are being shared. And so that's the dot and cross diagram. And remember, the hydrogen atom should have the cross or either way around. One atom should have either the cross or the dot. So that means if Cl has the crosses, as showing their outer electrons, hydrogen should have the dot. Okay, so question 5A2 is saying hydrogen chloride has a low boiling point. Put a cross in the box to show the reason for this. So the first thing it says the covalent bonds are strong, the covalent bonds are weak. There are weak forces between the ions, there are weak forces between the molecules. Now what determines boiling point? Okay, so like let's say we had HCl, so this is our HCl molecule. The thing is, whenever you're melting or boiling something, what you're doing is you're actually breaking the forces between different molecules. And please don't get this confused with breaking forces in between the molecules, because if you're breaking forces over here, if you're breaking the forces between the atoms, that means you're actually splitting the atom. But when you're boiling something, you're actually breaking these forces, these intermolecular forces. So if something has a low boiling point, that means that there must be weak forces between the molecules. Okay, so that's the answer. So if it had a high boiling point, there would be strong forces between the molecules. So what it says is that hydrochloric acid, in 5B1, it says hydrochloric acid is a solution of hydrogen chloride in water. So give the formula of the species that makes the solution acidic. So when you have HCl, and you have a beaker, and there's water in this beaker, and you add hydrogen chloride to it, what happens is an acid is formed. Now what makes any solution acidic, and why does this acid form? So basically what happens is, I'm going to explain it to you. When you add HCl to water, what happens is that it splits into ions, okay? So it combines with the water, does some chemical stuff, and it splits into ions, H plus and Cl minus. And what happens is that this H plus ion, right, over here, that helps create the acidity. Okay? So in any form of acid, as you'll notice, it's usually H2SO4 or like H2CO3. As you notice, all acids will have this hydrogen in them. Okay? So that hydrogen is the one that actually creates this acidity, because when hydrogen is dissolved in water, it will form the H plus ion, and this H plus ion will create acidity. So the formula of the species that makes the solution acidic is just H plus. So explain why there's no color change when universal indicator paper is added to a solution of hydrochloric acid and methylbenzene. So what happens when hydrogen chloride is actually dissolved in methylbenzene is that it doesn't form that H plus and Cl minus like it does in water, and so it doesn't form an acidic solution. Because if there are no H plus ions, that means there's no acidity, and that means there's no acid. So the reason that there's no universal color change is that H plus ions aren't formed when HCl is dissolved, hydrogen chloride is dissolved in methylbenzene. Okay, so question 5C1 that says that when hydrochloric acid is added to solid potassium manganate, chlorine gas is given off. So Cl2 gas is given off. So Cl2 gas is given off. Describe what is seen if a piece of damp universal indicator, so let's say this is our thing and chlorine gas is coming out, yeah? And let's say we put this piece of damp universal indicator paper, okay? So this damp universal indicator paper will actually be red, right, at the start. But then when the chlorine comes into contact with any damp piece of universal indicator paper, what happens is it bleaches. It bleaches the universal indicator. So this will start becoming white. So it turns from red to white. And the reason it'll be red at first is because when a universal indicator paper is red, that means there's an acid. And in this case, there's hydrochloric acid. So that means that the universal indicator paper will be actually red in the beginning because of the acid. But then after the chlorine comes into contact with the universal indicator paper, it'll start bleaching it. And this is something you have to memorize. It's not something I can teach you. So when chlorine comes into contact with universal indicator paper, it gets bleached. So the answer is actually it turns from red and then it gets bleached to white. Yeah? Sorry for the writing. Okay, so 5C2. Chlorine exists as two isotopes. Why do these isotopes have identical chemical properties? So, first of all, what you need to know is chemical properties are actually determined by the number of outer electrons. Okay? Just remember that. Okay? So chemical properties are determined by the number of outer electrons. Okay? Because if you have the similar number of outer electrons, that means you lose the similar amount or gain the similar amount of electrons, and therefore you'll have the same reaction. Okay, but isotopes, what they have is the same number of protons, right? So they have the same number of protons and therefore they have the same number of electrons, but they have different numbers of neutrons. Okay? So then they don't have the same number of neutrons. Okay, so they'll have different masses. So if they have the same number of electrons, right, they should have the same electron configuration. Okay? And if they have the same electron configuration, for example, if it's 284, if two isotopes will have the same electron configuration 284, that means that this outer electron, the outer valence electrons, they'll have the same number of outer valence electrons. So the reason for them having identical chemical properties is that they have same number of outer electrons. Or just, you can just say same number of electrons. That's more accurate. Okay, question 5D says, iron forms two chlorides, iron 2 chloride, so that's FeCl2, and iron 3 chloride, which is FeCl3. So you got to describe a chemical test that you would use to distinguish between these compounds. Now these chemical tests are something you should kind of know. It's kind of a memorizing thing. So to distinguish between these two, you would have to add sodium hydroxide, okay? And sodium hydroxide is just NaOH. Okay, and what would happen is if you did FeCl2 plus NaOH, you would get NaCl plus FeOH2. I haven't balanced it, but this FeOH2 actually has a green color and it's a solid. So that means that you'll have a green precipitate. Yep, for FeCl2. And over here with iron 3 chloride you'll form FeOH3, and that is actually a brownish, orangish brown precipitate. So orangish, orange, just ignore the writing, brown, precipitate. And that is your two answers. Alright, question 6A1. They've showed you the sequence of reactions involving ethanol, and they're asking you what type of substance C6H12O6 is. Now, hopefully you should know this from biology and the fact that you've encountered it so much in high school. C6H12O6 is just glucose, or you can just say sugar. Sugar is a better word to use, I would say. So 6.2 is asking you to write the empirical formula of C6H12O6. Now, what is the empirical formula? Empirical formula is the simplest ratio of atoms to atoms in a compound. So, for example, if I had C2H4, I could divide both by 2, and I would end up with CH2. And that's the simplest ratio of carbon atoms to hydrogen atoms. So in this case, it's C6H12O6. If I divided all of these by 6, I'd get C1 or C, H2O. And that is the simplest ratio of carbon to hydrogen to oxygen in this molecule. Okay, so reaction 1 is used to prepare ethanol by fermentation. State 2 conditions used in this process. So first of all, for fermentation to take place, there needs to be anaerobic respiration. So that means that there needs to be no air or no oxygen, right? So that anaerobic respiration can take place and this can be produced. Ethanol can be produced, sorry. And also, what you need is, you also need yeast, because yeast is like a bacteria which kind of ferments. Yeah, it's a fermenter, and it helps produce the ethanol. Alright, so 6C says that ethanol can be made by the hydration of ethene. Write a chemical equation for this reaction. Now, as you probably know, ethene has 2 carbon atoms, and it's an alkene, so it should have 4 hydrogen atoms. And the hydration of ethene means you're adding water to it. And what this actually becomes is actually C2H5 and OH. So what happens is the oxygen bonds with one of the hydrogens, and then the remaining hydrogens and carbons just bond together. Okay, so for this hydration reaction, where you industrially hydrate ethene, you need certain conditions, and in this case, the conditions would be a high temperature, because you want the reaction to occur fast. So you need a high temperature for a fast rate of reaction. So high temperature, ignore it if it doesn't say temperature fully. And you need it from like a range of 250 to 350 degrees Celsius. And also what you need is a high pressure, because high pressure will help you produce more of the C2H5OH. You have to 6D, you have to state 2 reasons why countries such as Brazil would make large quantities of ethanol by fermentation instead of the hydration of ethene. Now, first of all, Brazil would make large quantities because, first of all, petroleum is really expensive. So petrol is expensive, so just a lot of money. So obviously they're going to choose to make ethanol, which is a much cheaper option for them. Also, they have lots of sugarcane. Lots of sugarcane is grown in Brazil, and so they have a lot of sugarcane and glucose, like sugarcane is basically that C6H12O6, which can be used in the fermentation process, and so since they have a lot of sugarcane, they can use a lot of it in the fermentation process instead of actually in the hydration of ethene. Alright, question 6E1 is asking you what is happening in reaction 2 over here. So basically what you have here is C2H5OH, and then over here what you have is C2H5ONA. So that means that the hydrogen has actually been displaced by the Na. So what has been done, what has been added is basically just Na, or sodium. And 6E2, you just have to name the product, which is C2H5ONA, and the name of this product is just sodium ethoxide, right? Because the sodium is over here, and C2H5O is ethoxide, and eth is because of the 2 carbon atoms, and the oxide is because of the oxygen. Okay, you have to predict the type of bonding between O and Na in the compound C2H5ONa. And this actually is just simply ionic bonding. This whole question 6 was actually, it's not included in the recent IGCSE board, meaning it's been taken off of the IGCSE exams actually. So you don't really need to worry about it and worry about the explanations I've just given you. I know they're not that great, but I just wanted to do them. And if you have any questions, you can comment below, but they're not included really in the new syllabus, so it's no point really studying them. Alright, so 7A1, it's basically 7A is drawn to sulfur molecules, and they're asking you what is the formula of one molecule of sulfur. Now this is just basically one molecule of sulfur, and the symbol for sulfur is S, right? But there's 1, 2, 3, 4, 5, 6, 7, 8 atoms of sulfur in one molecule, so it's just simply S8. Question 7A2 is asking you what is represented by each of the lines labeled 1 and 2. So if we look at 1, right, it's the forces between 2 atoms. And as you probably know is that sulfur atoms share electrons with each other. So that means that it represents the covalent bonding, right, between the sulfur atoms. So covalent bonding, or we call this actually intramolecular force. And they ask you what number 2 represents, and number 2 is just basically the forces between 2 molecules over here. So 1 molecule here and 1 molecule here. So it's just simply the intermolecular force. That's what we call it. The force between 2 molecules is intermolecular force. Alright, so in the contact process it says sulfur dioxide. Dioxide means 2 oxygen. So sulfur dioxide is converted to sulfur trioxide. And you have to write a chemical equation for this reaction. So what is the difference between sulfur dioxide and sulfur trioxide? It's just oxygen, right? So that means that it must have just been added to oxygen. Sulfur dioxide must have been added to oxygen. So it's just simply SO2 plus O2 will give you SO3. Now, the job's not done yet. You got to balance. So all you have to do is, so if I put 2 here, I'm going to have 2 S's and 6 O's. And over here I have 4 O's and 1 S. So if I put a 2 in front of S, I'll have 2 S's and 6 O's on either side. 2 S's and 6 O's on either side, so it's balanced. Oh, and sorry, I made a kind of mistake over there. The reaction is actually reversible. Okay? So that's my bad. The reaction is actually reversible. So it's 2SO2 plus O2, and it can go both ways, meaning it can go both ways. Okay? So yeah. Okay, so 7B2 is asking you 3 conditions that are needed in this conversion. So first of all, it's a reversible reaction. So in order for a lot of SO3 to be produced, using our knowledge of Le Chatelier's principle, we need to increase the pressure. So we need to have high pressure. Okay? And the high pressure should be about 1 atmosphere. Atmospheric pressure, 1 atmospheric pressure. Also what we need is actually, so this is the first condition. We need a catalyst to speed up both reactions so that it's produced faster. So the catalyst should be, in this case, vanadium oxide, which is V2O5. So vanadium oxide as a catalyst. So it speeds up both reactions. And in this case, we also need to increase the temperature. We need to have a high temperature so that high amount, the rate is fast, and so a high amount of SO3 can be produced. So question 7C1 says that sulfur trioxide in the atmosphere causes acid rain. You got to write a chemical reaction for the formation of acid rain by sulfur trioxide. So sulfur trioxide is SO3, and in the atmosphere causes acid rain. So the only way it can cause acid rain, in the atmosphere what we have is actually water. So if it mixes with water, it can actually form an acid, and this acid is just commonly known as sulfuric acid or H2SO4. and that is the equation of your reaction. But you gotta balance it, I think. Actually, no, you don't have to balance it, it's balanced. So that is the equation of your reaction, because sulfur trioxide, it mixes in the water and it forms this acidic solution of sulfuric acid. Okay, 7C2 is just asking you what are the harmful effects of acid rain on the environment. First of all, acid rain, I'll give you a simple one. Acid rain can go into rivers, and fish can be killed. Because obviously if acid is not that safe, and so fish can be killed or harmed because of the acid like reacting with them, and acid is really corrosive, so it's dangerous for them. Also, stonework or statues, right? Stonework / statues are eaten away or corroded because of the fact that acid just basically reacts with the stone on the statues and it just corrodes it away and it kind of damages that stuff. So stonework, I mean, don't say statues, say just stonework. Stonework is eaten away or corroded. Okay, so question 8A1 is asking you to describe the structure of a metal such as magnesium. Now, any metal has metallic bonding. Now, what is metallic bonding? So let's imagine here that we have all magnesium atoms, so magnesium atoms. And from your common knowledge is that all metal atoms will lose electrons. So each of these magnesium atoms will lose electrons and they'll become positively charged. Correct? So all of them will be positive charged. But then what will happen to these electrons? Will they just go out? Or what will happen to them? What actually happens is that these electrons actually stay inside the structure. Okay? And so there's this giant structure, this 3D structure of positive electrons, and there's a sea of electrons within this structure. Okay? So this just forms this whole 3D structure, so there'll be like 3D, sorry, I suck at drawing. So there'll be like this 3D box structure or whatever. Lattice, we call it a lattice. There'll be this 3D structure of positive ions, right? And then there'll be all of these sea of electrons in between. So the structure would actually be a giant, I'll just recite it, a giant regular lattice structure of positive ions, and within this there's a sea of delocalized electrons. And this applies to any metal, Okay, so question 882 is, they're asking what is meant by the term malleable. Now, malleable basically means when I smack something or smack a substance, it can be smacked and beaten or hammered and formed a really thin shape or a thin sheet. So what it means is, so a quick definition would be a substance. I'll just recite it to you. A substance that can just be hammered and smashed to form a thinner shape, such as a sheet. And so that's malleable. Okay, so 883 is asking to explain in terms of its structure why magnesium is malleable. Now, first of all, I want you to look at this diagram. So let's say there's this hammer, and this is the structure of magnesium, as you remember from the beginning of the question. And let's say it smashes this atom, structure of magnesium. What will happen is that these positive ions will move in this direction, and these ions will stay here. But the thing is, they won't crumble. The structure won't crumble because of the strong attraction between these electrons and the positive ions. So basically, what happens is that the positive ions, they'll slip over each other, but structure will not collapse. The structure will not, I'll just recite it. The structure will not break because of the strong electrostatic attraction between the delocalized electrons and the positive ions. Okay, the 8C1 is asking you to give the electron configuration of a fluorine atom. So fluorine atom actually has 9 protons according to the periodic table, meaning it has 9 electrons. So in the first shell there will be 2 electrons, and in the second shell that means there will be 7 electrons. So that's the electron configuration of fluorine. Now for 8C2, they're asking you to find the electron configuration of a fluoride ion. Fl negative. So fluoride ion is when, since it has 2, 7 and 7 in its outer shell, it's much easier for chlorine to gain one more electron. So that means now it'll gain one more electron. So from 9 electrons, it'll get 10 electrons. So that means that its new electron configuration will be 2, 8. And so it has a full outer shell. And the charge will be fluorine, and it'll be 1 negative sign, because it gained 1 electron. Okay guys, please go on to watch part 3. I have not finished with the 8th question. I'll finish it in the next part. Thank you for watching. Comment, rate, subscribe. Comment if you have any questions. Rate this video 5 out of 5 please, and subscribe to my channel. And I'll see you guys on the next video.